Hello everyone, so today we're going to go over the end behavior of polynomials. The end behavior of polynomials has a lot to do with the highest power. So essentially you have to look at the highest power of the polynomial, and then you also have to look at the leading coefficient, so the coefficient on the highest power there. If the leading coefficient is even, and you have, if the highest power is even and the leading coefficient is positive, the end behavior of the polynomial, essentially the polynomial is going to go up to positive infinity in both directions. What does that mean? So that means that as x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to positive infinity, all right? Kind of the way I remember this one is it goes up, up, all right? Then, if we have an even degree but a negative leading coefficient, that means that as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to negative infinity. Basically, both ends of the graph are going to go down to negative infinity. All right, and this is an example here. I guess I should have shown this here, right? We've got a even highest power and then a positive leading coefficient of 1. So that's why it's positive and even. This one is negative and even, right? So we've got a even highest power and a negative leading coefficient. Then we've got odd degrees. So if you have an odd highest power and the leading coefficient is positive, as x goes to negative infinity, y, or f of x, is going to go to negative infinity. As x goes to positive infinity, f of x is going to go to positive infinity. And of course, we can see here we've got an odd highest power and a positive leading coefficient. So this guy goes down and up. All right, and then we have a odd degree, but a negative leading coefficient. So as x goes to negative infinity, y, or f of x, is going to go to positive infinity. As x goes to positive infinity, y, or f of x, goes to negative infinity. It's going down. And of course, we can see here we got an odd highest power and a negative leading coefficient. All right, so let's see how this kind of plays out here. All right. So if we look here, they want us to fill in this information. We got to figure out the degree, the leading coefficient, and the number of zeros, or real zeros, and maximum values. So we can get all this just from looking at the graph. So if we look at the end behavior, we can see that as x goes to negative infinity, f of x goes to positive infinity, right? As x is going that direction, the function's going up, all right? And then as x goes to positive infinity, meaning this direction, f of x, our function, is going to go to negative infinity. And basically, just by looking at these end behaviors, we could see, well, where do we have it going up in that direction and down this direction? We're going to have an odd degree and a negative leading coefficient. All right. Then they want us to look at the number of zeros. So we've got 1, 2, 3, 4, 5, 6. All right. So we have 6 distinct zeros, and then they want us to put the number of maximum values. So the maximum values are going to be the tops of these little bumps here. So we've got 1, 2, 3 maximum values, relative maximum values. All right. Now let's take a look at this one. So just from looking at this, we can see that the end behavior is down and down, right? We've got it going down, got it going down. So what that means is that, well, I guess we also could just use this chart up here, right? Which one has it down and down? That's going to be even with a negative leading coefficient. And then this is the end behavior here. So essentially, as x goes to negative infinity, meaning in this direction, the function is going to negative infinity. It's going down. All right. Ooh, thought I was erasing. Then as x goes to positive infinity, f of x, our function, is going to negative infinity. So we could look here. So let's see. As x goes to positive infinity, we need it to go to negative. So positive to negative, it's going to be this one or this one. And then we need to go as x goes to negative infinity. The function goes to negative infinity. So that is going to be this guy right here. All right. All right. Now, instead of giving us the graph, they're just giving us the polynomial in standard form here. So what we have to do is we have to go find the highest power. So the highest power here is 6. All right. And the leading coefficient on this is a positive 6. So it's an even degree and positive leading coefficient. So if we go up here, even degree and positive leading coefficient, oops, we can see that it's going to fall into this category. So as x goes to negative infinity, f of x is going to go to positive infinity. And as x goes to positive infinity, f of x is going to go to positive infinity. So essentially what that means is that we're going to have n behavior of this. So as x goes negative infinity, f of x is going to go to positive infinity. And as x goes to infinity, f of x goes to positive infinity. So let's see, that looks like this guy here is going to be our answer. All right, let's do one more. So again, we have to look for the highest power. So our highest power is 5. So we've got an odd degree and then a negative leading coefficient. So odd degree, negative leading coefficient, we could look here. That's going to fall into this category right here. So as x goes to negative infinity, f of x is going to go to positive infinity. As x goes to infinity, f of x is going to go to negative infinity. All right. So we can scroll down back here. So as essentially we have this situation. So as x goes to negative infinity, we need to go to positive infinity. Negative to positive, and then as we go to positive, we need to go to negative. So this is going to be our answer right there.